Code considerations for architectural grade aluminum windows. Welcome to Building Knowledge 101. In this video, we'll present essential information about codes relating to architectural grade aluminum windows.
Okay, let's move to our last category here. And I want to talk about design options, installation options, and codes that might impact what window you choose. So the first code I want to look at is energy codes. All across the United States, we have energy codes. Now they vary from location to location, and there are different code standards that you might be falling under. So as an architect, when you start a project, you really need to be aware of what codes do I need to comply with. When it comes to energy codes, what you're looking at here is ASHRAE 90.1. This is one of the more common energy codes, but you might also be subjected to International Energy Conservation Code. So it's going to be one of these two. One of these codes is going to set thermal performance or energy requirements for your project. So make sure you know which one you're subjected to or you need to adhere to, and then follow it. Both these codes use the climate zone map that you can see here. So the climate zone map breaks North America into 8 different climate zones. You can see 7 of them here. So the first thing you as an architect need to do is determine where your project's located and which climate zone does it fall into. Now, if you look at Tennessee and Kentucky, they are completely within climate zone 4. So let's focus on climate zone 4. So once we've done that, we know what climate zone we're in. We're going to go now to our thermal charts, which is here. And this is going to tell us what the maximum U factor our frames are going to be allowed to have by code. So across the top row, it says climate zone. So you're going to move from 1, 2, 3 to 4. So we're under zone 4. So I boxed out a vertical box there under zone 4 to capture everything under it. Now over on the left side, you can see in bold fixed, operable, and entrance door. We're looking at operables. We're in that middle category, so I boxed that out in red too. So if you move across there to the right, where the box parallel to operable meets the box dropping down under 4, those two numbers are the values of our maximum U factors based on what code we're using. So over on the far right, you can see in green, I have International Energy Conservation Code. So if we follow that to the intersection of zone 4 with operable, if we're following IECC, then our operable windows can have a maximum U factor of 0.45. Then above that is ASHRAE 90.1. So if we're following 90.1, it says that the maximum U factors of the operable frames has to be no more than 0.46. So when we talk about the operable unit, that's a combination of the glass and the frame. So now that we know this is the maximum U factor that we can have, we need to start evaluating our product to make sure that it meets or will comply with that energy code. So every manufacturer that you're working with is going to have a thermal chart like this. This one's based on AMA 507. And in the left column, it says glass U factor. This is the center glass U factor for a number of different insulated glass units. And then the column on the right says overall U factor. So that is the system performance of that particular insulated glass unit in the frame that you're looking at. So I have underlined there 0.46 to comply with ASHRAE 90.1. So if that is a maximum U factor that we can have in this particular frame that this chart represents, moving to the left, you can see we can have an insulated glass unit with a center glass U factor of 0.34, and that will give us 0.46. So we meet ASHRAE 90.1's requirements for maximum U factor. Now you can have 0.44 or 0.43, that's fine, but you can't have 0.47. So the maximum U factor, with U factors, the lower the number, the better. So these codes are saying the U factor could be no higher than 0.46. So that's your starting point. Now, if you were looking at something like LEED, where you have a base performance level, and then you're going to earn credits by improving the thermal performance above and beyond that base performance level, then this is your starting point, 0.46, with an insulated glass unit that has a center glass U factor of 0.34. Well, you can see you can improve your glass performance down the left column and therefore improve the system performance also. So you can start incrementally improving the performance of that frame by improving the glass performance. Then if you wanted to move to triple glazing, you can improve it even more. So you can see a long range performance improvements that you can get going with a triple glazed unit. So that's how you're going to use these charts to start with your baseline performance. And then if you want to show incremental improvement, these charts will help you show how much improvement you can get by changing the glass or changing the frame from double glazed to triple glazed. Next thing you need to consider is wind speeds. This is a map from, it's ASCE 7, but this is used in International Building Code to establish wind speeds. You can see along the coastal area where it's in orange, that's where we've got high velocity wind zones, but also in the center of the United States. You can see we've got some red circled areas where wind loads increases. So if you're familiar with Texas Department of Insurance, they're starting to set standards for tornado impact in these areas. So even though you're not along the coastal area, do be aware of what wind zones you're in. And if there's certain codes now that are going to impact the building based on the wind codes. So if you're along the coastal area, IBC says if you're within a mile of the coast or the wind load is greater than 120 miles per hour, then you have to have systems that are tested in accordance with ASTM E1886 and ASTM E1996, and that evaluates large and missile impact upon the systems. And again, if you're in an area where Texas Department of Insurance or other standards, FEMA requires storm shelter construction, be aware of their requirements also for the type of glazing and the frames and the way the glass is installed into the frames to meet storm shelter requirements. You're working with a government project, working on a military facility, a courthouse, an embassy. Do be aware that in many cases, you're going to be required to meet minimum anti-terrorist standards or blast mitigation standards. So if you're working on a government project, you might have to provide systems that have been tested in accordance with Department of Defense's Unified Facilities criteria or General Services Administration standards. And this is requiring systems that have been tested for blast mitigation in a static testing, a shock tube, or arena test. So be aware of that. Certain government projects require blast mitigation. So you're going to be looking for projects that comply with that. Then ADA, we're all familiar with that. Americans with Disability Act. It's had a big impact on windows. So it has a lot of impact on the windows that you're going to be using. Hardware can't be located any higher than 48 inches from finished floor. Then single point operation of hardware is required without grasping or twisting. So you can't have hardware that requires somebody wrapping their hand around it and grabbing it and rotating it. It can't require that. Operating force can't exceed 5 pounds. And then again, single action hardware with multi-points is very, very common to comply with ADA requirements. Here you can see a nice high-rise multifamily project, and there's a casement. The unit on the right of this glazed elevation is a casement unit. You can see where the window is located. The hardware is within 48 inches of the finished floor. So according to code, it's located where it has to be, but it has to be a single point multi-point lock, single cam multi-point lock. So the lowest cam that you see on the window, when it's rotated, it operates and releases the lock stacked above it. Same in this configuration, the same. You've got a multi-point lock here, 2 casements on each side of this elevation, and a single point operates all the hardware up and down that elevation. So that complies with ADA, keeping the hardware within location and a single point. Hardware like this is becoming very common, very popular. What this hardware does, you can see there's a handle there, and you can put your hand or an arm inside of that and rotate it around 180 degrees. And as you do, as you rotate that, it releases the locking mechanism and then pushes the window out and holds it in an open position. Then when you rotate the handle back around the other direction, just a simple sweeping motion that doesn't take a lot of force, it pulls the window back in closed and engages the lock. So it's one operation, one handle that does unlocking the window, opening the window, and holding the window open, then sweep it back the other way and reverses that. So hardware like this, you're seeing expanded use of because it complies with ADA, makes it very, very easy to open and close windows. International Building Code, I mentioned earlier, emergency egress windows. So that is part of IBC 1030. And what IBC 1030 goes on to talk about is for emergency egress windows, you have to have a minimum clear opening of 5.7 square feet. Then also minimum opening height of 24 inches. Now it can be taller, but no less than 24 inches. And then the width, minimum width of 20 inches. It can be wider, but no narrower than 20 inches. And then the sill of the window can't exceed 44 inches from the finished floor. And then the window has to open, providing a clear opening. So you can't use floor bar friction hardware, which is very common. It has to be butt hinges or close-up hinges so that as the windows open, it swings clear of the opening, gets clearly out of it so that people escaping won't get hung up on handles or hardware on the unit. So again, be aware of that if IBC 1030 does impact your project. Something else that IBC talks about is in 1015.8 window openings. Now this impacts windows where the sill is less than 36 inches above the finished floor or no more than 72 inches above the grade on the outside. So if you're looking at windows in a high-rise multifamily project, this is where it's more common. IBC says, kind of to summarize it, that when the window opens up, it has to be limited so that a 4-inch diameter spear can't be pushed through any place along the opening of the window. So your hardware has to limit the opening for life safety purposes that a 4-inch spear can't pass through the opening of the window. So that's very common across all windows. And when you're using multifamily projects, they all have limiting of some type. Here you can see a keyed limit arm. Now what this does is it can be set to limit the opening of the window so it complies with and meets the requirements of IBC, but it has a custodial key that when you want to clean the window, you can release that, swing the window further so you can access the exterior from the inside and clean the window, then draw it back in, re-engage the limit arm, and it stops the opening of the window, maintaining the code requirement, preventing a forward spear getting through the opening. So certainly be aware of that. You've got to have opening limitations.
That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.